Welcome to the notes on skill number 43 of Unit 6 for Geometry. Skill 43, I can prove and apply and use theorems about properties of parallelograms to solve problems. We'll begin our notes on page 43A. This section is about parallelograms. First, we should define a parallelogram. A parallelogram is a quadrilateral, which means it has four sides, a quadrilateral with two pairs of parallel sides. So we've drawn a parallelogram here, which we identify as parallelogram ABCD. And as you can see, sides AB and CD are parallel with one another. Likewise, BC and AD are parallel as well. When we're writing about it in our notebooks, we can use the parallelogram symbol right here to annotate it. So parallelogram ABCD is drawn above. There are four theorems about parallelograms, which I've broken down as foldouts for us to use. They're called the properties of parallelograms, and the first property is about the opposite sides. If we open up the foldout on the inside, I've written the first property of parallelogram, and it is about the opposite sides. If a quadrilateral is a parallelogram, then the opposite sides are congruent. So not only are they parallel, but they are also of equal length. AB is congruent to CD, as well as AD is congruent to BC. On page 43B, I've listed the other three properties of parallelograms as foldouts. We have the opposite angles property, we have the consecutive angles property, and the diagonals property. If we open up these three flaps, we see under the opposite angles property that if you have a parallelogram, if you have a quadrilateral that is a parallelogram, the opposite angles will be congruent. So angle A is congruent to angle C, and angle D is congruent to angle B. When we look at the consecutive angles, it states that if you have a quadrilateral that is a parallelogram, then the consecutive angles are supplementary. What that means is if I add angle A to angle B, I get 180 degrees. I can do the same if I add angle B to angle C. Those two are supplementary as well. And on down the line, C plus D is 180 and D plus A is 180. All consecutive angles are supplementary. And the final property of a parallelogram is about the diagonals. If we draw the diagonals of our parallelogram, we'll find that they bisect one another. In other words, AZ is going to be congruent to ZC, or BZ is congruent to ZD. That's the four properties of the parallelogram. Let's take a look at an example on the next page. On page 43C, we're going to look at example 1, which states, use properties of parallelograms to solve for x, y, and z. And we're given a diagram here. The diagram is of parallelogram JKLM, which if we wanted to, we could write as parallelogram JKLM. We're also given diagonals which intersect at point N, and then various measurements along the way. So the first property that we can use is the property of opposite sides, which was the first one I introduced, and it states that the opposite sides are equal to one another, and that they are congruent. So side JK is congruent to side LM. So if that's true, then length JK is equal to length LM. And we can create the equation 5x equals 3x plus 20. Solve that down to x equals 10. The second property, or actually this was the third property that I shared, was about consecutive angles. And that property said if you have a parallelogram, consecutive angles are supplementary, which means that the measure of angle M plus the measure of angle L will equal 180 degrees. So we substitute those values in for M and L, and we get the equation 8z plus 2 plus 20z plus 10 equals 180. And if we simplify that equation down, we arrive at z equals 16. And the last property I shared was the property of parallelogram about their diagonals, which states that diagonals bisect each other. So if that's true, then Jn is equal to NL. So we substitute those values in. The value for Jn is 3y minus 15, and we set that equal to 2y, and we can solve for y, as shown right here. Final page of notes for the skill 43D is conditions for parallelograms, and we have 1, 2, 3, 4, 5, 6 possible conditions. If any of the 6 conditions are met with a quadrilateral, then we know we have a parallelogram. Our first condition is both pairs of opposite sides are parallel. So that's the definition of a parallelogram. So when that happens, we know for sure we have a parallelogram. Our second condition says if we have a quadrilateral and one pair of opposite sides is parallel and congruent, then you have a parallelogram. Another condition is if both pairs of opposite sides are congruent, then you have a parallelogram. The fourth condition that says if both pairs of opposite angles are congruent, then you have a parallelogram. Our fifth condition states that if one angle, we'll say angle B, is supplementary to the two consecutive angles, then you have a parallelogram. So if B and A is supplementary, as well as B and C, then you have a parallelogram. And the final condition is if the diagonals of your quadrilateral bisect each other, then you have a parallelogram. If any one of these are met, then you can state that your quadrilateral is a parallelogram. For example, if you're given a condition where you had a quadrilateral with the following dimensions, 7, 18, 7, 18, you could go to the various conditions and look down it and say, both pairs of opposite sides are congruent. 7 and 7 are congruent, 18 and 18 are congruent. Because this condition is met, we have a parallelogram. Alright, skill number 43 covers 2 sections out of the textbook. The skill test for it, we need to keep in mind these keywords and ideas. We should be able to draw and identify parallelograms. We should know the properties of parallelograms, those being the opposite sides are congruent, opposite angles are congruent, consecutive angles are supplementary, and diagonals bisect one another. We should also be able to identify conditions for parallelograms. So if you had two sides that were congruent and parallel, then you would have a parallelogram. Alright, this concludes the lesson for skill number 43. Thank you.